You know that feeling when you're in a status meeting?
Oh, yeah.
The project is, technically marked green on the dashboard, maybe light line green, but
hmm
if you actually look around the room, everyone looks like they haven't slept in a week.
The green status, that is exactly one bad compile away from a catastrophic red.
Exactly. It feels like you're walking through a swamp. You take one step forward, your boot gets stuck, you pull it out, and you realize you've, lost a sock.
And when you ask why, you get the same answer.
Every single time. Well, you have to understand, it's a very complex project.
It's the ultimate shield. Complexity, it stops all questions. It implies that chaos is inevitable, like bad weather.
Right. You can't fight the weather, right? You just have to endure it.
Mm-hmm.
But here is the question that kept me up reading the material for today. Is the project actually complex?
Mm-hmm.
Or have we just created a giant mess and decided to label it complexity so we don't have to feel bad about it?
And that is the uncomfortable question at the heart of today's deep dive. We are unpacking the complex product development model, or CPDM, created by Krister Sandel.
And the source material is interesting today. It's not a dry textbook or anything.
No, not at all.
It's a dialogue. It's a script between a skeptical operational manager, who is, every frustrated boss ever, and a CPDM strategist, who is trying to explain why traditional engineering management is broken.
And the mission for this dive is pretty specific. We aren't just here to complain about bad projects. We want to figure out how to regain what Sandel calls intellectual control.
Right.
We need to learn the difference between the hard problems we have to solve and the messy problems we create for ourselves.
And we're going to talk about why having a rock star developer or a guru on your team might actually be the single most dangerous risk to your company.
Mm-hmm.
Which, I'll be honest, sounded ridiculous when I first read it. I thought the whole goal was to hire geniuses.
It's very counterintuitive, but by the end of this, I think it'll make perfect sense. It's about the difference between a real team and just a collection of egos.
Okay, so let's start with the diagnosis.
Yeah.
In the source dialogue, the skeptical manager, he describes his reality as a morass, just a bog of issues.
Mm-hmm.
He's impatient, he's worried about money, and he basically tells the strategist, look, we call this complex, but I think we've just built a disaster.
And the strategist, let's call him the expert here, immediately pushes back on that word complexity. And this is like the first big insight. In most companies, complex is used as a synonym for difficult or just big.
A lot of code, a lot of people, so therefore it must be complex.
But CPDM has a very, very strict definition. Complexity is defined as something that is not sufficiently understood or predictable.
So if I can't tell you what's going to happen when I push this button, it's complex.
Actually, it goes even deeper. If you cannot predict the result of your actions, Sandel argues you aren't dealing with complexity anymore. You are in chaos.
That's a distinction with teeth. Because complexity sounds sophisticated, Sounds like you're doing rocket science.
Exactly.
Chaos sounds like incompetence.
Precisely. If you change a line of code or adjust a system specification and you have to just cross your fingers and hope nothing breaks, that is chaos. You've lost control.
Okay.
And this leads us to the core framework of CPDM, distinguishing between intrinsic complexity and artificial complexity.
This was the light bulb moment for me reading this. Break down the difference for us.
So intrinsic complexity is the difficulty that's just inherent in the problem you are solving. If you are building a pacemaker, you have intrinsic complexity.
Right.
It has to be small, the battery has to last 10 years, and it absolutely cannot fail or someone dies. You can't just wish that difficulty away. That's the job.
That's the real work. Gravity, physics, market regulations, those are the constraints given by reality.
Exactly. But artificial complexity, that is the complexity we inflict on ourselves. It comes from using the wrong models, the wrong architecture, or just bad habits. It's difficulty that doesn't even need to exist.
It's like tripping over your own shoelaces while you're trying to run a marathon. The marathon is hard, that's intrinsic, but tying your shoes together, that's artificial. That just makes it impossible.
Perfect analogy. And in engineering, we tie our shoes together constantly.
The source material uses this fantastic historical analogy to explain artificial complexity. And I know you love a good historical detour.
Oh, the epicycles. This is the perfect metaphor for modern legacy code. It's almost spooky how well it fits.
So set the scene for us. Medieval astronomers are looking at the sky. They have a model of the universe.
Right. They believe in the geocentric model. The Earth is the center of the universe, and everything, the sun, the planets, revolves around us in perfect circles. That was their system architecture, you could say.
If there was a bug in the system.
A big one.
When they actually observe the planets, specifically Mars, it didn't move in a perfect circle. Sometimes it looked like it was moving backward, it wobbled, it just didn't fit the model.
Now, a scientist today would say, okay, the model is wrong. But these astronomers, they were locked in. They couldn't change that core belief.
So what did they do?
Instead of changing the model, they patched it. They invented epicycles.
Circles within circles.
Yes. They said, okay, Mars isn't just orbiting the Earth. It's orbiting an invisible point that is orbiting the Earth. And when that math didn't quite work, they added another circle on top of that one, and another.
They ended up with these mathematical monstrosities. I've seen the diagrams that looks like a spirograph gone wrong.
It was unbelievably complicated. You had to be an absolute genius to calculate where Mars would be next Tuesday. But here's the kicker. Was that complexity real? Was the universe actually that complicated?
No. As soon as Copernicus and Kepler came along and said, hey, maybe the sun is in the center, all the circles just vanished. The orbits became simple ellipses.
Exactly. The complexity wasn't in the sky. It was in their bad map of the sky. That is artificial complexity.
So bringing this back to our skeptical manager and his engineering team, the CPDM strategist is basically telling him, your team is building epicycles.
100%. When an engineering team says, this system is so complex, we need 5 layers of middleware, 3 interpretation patches, and a custom script just to get the database to talk to the user interface.
They are drawing epicycles.
They are. They're adding layers of work to compensate for the fact that their underlying model of the system is just wrong.
And the tragedy is, they probably feel like heroes, right? They're staying late, they're solving these incredibly hard math problems to make all the circles fit.
They're working very, very hard on problems that shouldn't even exist. They're managing the circles instead of changing the model. That's why the project feels like a swamp.
Right.
You aren't fighting the intrinsic difficulty of the product. You're fighting the artificial mess you created.
It creates this illusion of productivity. Look how busy we are.
Right.
But you're just busy fixing the patches you applied to the last patches.
Correct. And this leads directly to the question of who is building these epicycles, which brings us to the most controversial part of the source material.
The guru.
Guru.
Now, in most tech circles, being called a guru is the goal. That's the highest compliment. It means you're the wizard, the 10x engineer,
Yeah.
the person who can see the matrix.
Right. But the CPDM dictionary definition, and I have it right here, is just brutal. It defines a guru as a developer who prioritizes their own ego over the company's best interest.
Whoa. Okay. That flips the script entirely. It frames the guru not as an asset, but as a liability.
It does. And I want to be clear, it's not saying that being smart is bad. It's about how you use that intelligence that matters.
But let me play devil's advocate for a second.
Yeah.
The skeptical manager in the dialogue, he pushes back on this hard. He says, but these guys are the only ones who can fix the bugs. They're the only ones who understand the deep code. He's terrified. He thinks, if I fire my guru, the whole project stops.
And that is exactly the trap. If only one person understands the code, you don't have a product. You have a hostage situation.
A hostage situation? That feels a bit dramatic.
Is it? If that guru gets hit by a bus, or gets a better offer from Google, or just decides to be in a bad mood, your entire business creates 0 value that day. The project doesn't belong to the company anymore. It belongs to that person's memory. The source calls this building monuments to their own skill.
Monuments to their own skill. That's a sticky phrase. It implies they are building it just to show off, not to be useful.
They write code that is so clever, so obscure, and uses such specific tricks that only they can decipher it. It makes them indispensable, sure, but it makes the entire system fragile.
It's job security through obfuscation. I've definitely seen that. You ask how a module works, and the answer is, don't touch that. Only Dave knows how that works.
And CPDM says that is a failure of engineering. It's craftsmanship gone wrong. It creates bottlenecks because every decision has to go through Dave. It creates opacity because no one else can audit the quality. It's the exact opposite of scalable engineering.
It reminds me of the epicycles again. The guru is the only one who understands all the circles. So you have to keep paying the guru to calculate the orbits.
Exactly. And the guru loves it. They get to be the hero. Every time the system crashes, they swoop in, type furiously for 10 minutes, fix the bug, and everyone applauds. But a true engineer would have built a system that didn't crash in the first place.
So, okay, we've identified the enemy, artificial complexity, the epicycles, and the guru, the keeper of the secrets. So what is this solution? What is the alternative?
The alternative is intellectual control.
Sounds a little Orwellian. Intellectual control. What does that actually mean in practice?
It means shifting from a culture of oral tradition, asking Dave, to a culture of formalism. Intellectual control means the result, the product, the system. It's so well described and formalized that you can verify it is correct just by inspecting it.
Inspecting it, you mean like looking at the design, not running the code.
Correct. And this is a huge shift for most developers. We are addicted to trial and error. We write some code, we hit compile, we see if it crashes. If it crashes, we change a variable and try again.
The move fast and break things method.
The CPDM strategist calls that guessing.
Ouch.
He compares it to civil engineering. Imagine if we built bridges the way we build software. You throw up some steel beams, drive a truck over it, watch it collapse into the river, and say, oops, let's try more cement next time.
Yeah, we wouldn't accept that. We expect the engineer to calculate the load before a single beam is placed.
Exactly. A civil engineer has a blueprint. They have physics calculations. They have intellectual control over the bridge before it even exists physically. CPDM argues software should be the same. You shouldn't have to run the code to know what it does. You should be able to look at the model and prove it works.
But this implies a heavy emphasis on documentation, though. And I can hear the Agile crowd screaming right now, documentation is waste, working software over comprehensive documentation.
And that is the tension. But CPDM argues that working software that no one understands isn't actually an asset, it's a liability. The formalism here isn't about writing 500-page Word documents that no one reads.
Yeah.
It's about having a common language.
A common language.
Yes, a way of modeling the system visually, logically, so that anyone on the team can look at a feature and understand exactly how it functions without needing a seance with the guru. It democratizes the knowledge.
So it moves the power from the individual hero to the system itself.
Precisely. It shifts the focus from individual heroism, where Dave saves the day at 2 a.m. with some brilliant hack-to system clarity, where Dave can actually sleep because the system works as designed.
I like that distinction, moving from hoping it works to knowing it works. But the skeptical manager in the dialogue raises the point that I think every listener is thinking right now. He says, we are already behind. We are drowning. You want us to stop and spend more time on formalism and modeling. Won't that just slow us down?
It's the classic paradox. I'm too busy mopping the floor to turn off the faucet.
Right. But in the short term, mopping feels productive. Turning off the faucet takes time you don't have.
But the strategist hits him with the opportunity cost. And this is where the engineering problem becomes a business problem.
Okay.
If your team is spending 80% of their time fighting artificial complexity, debugging the guru's opaque code, fixing the epicycles, dealing with all the chaos, that is time they are not spending on creating value for the customer.
80%. If that number is even close to real, that's staggering.
In chaotic projects, it's often higher. I mean, think about your own week. How much time did you spend building something new versus fixing something that broke?
I don't want to answer that.
Exactly. And the so what here is brutal. While you are busy wrestling with your own bad internal models, your competitor, who might have intellectual control, is busy building new features that the market actually wants.
So the engineering chaos is directly stealing from the business bottom line. It's not just an IT problem.
Absolutely. The source warns against engineering-driven development. This happens when you let the engineers build whatever they want, however they want. They might build something incredibly complex because it's intellectually stimulating for them.
Or because the guru wants to try a new framework. Resume-driven development.
Yes. But the market doesn't care about your framework. The market cares about utility. If you can't deliver what the market needs quickly and reliably because you're stuck in your own mud, you fail.
There's a moment in the dialogue where the skeptic finally seems to get it. He stops fighting.
Yeah.
He says something like, we need to clean in front of our own door first.
Yes. That realization is key. He admits they are in chaos.
Yeah.
And admitting that is step one. You have to stop pretending that the project is just complex and admit, no, we have lost control. We don't understand our own system.
It requires a lot of humility.
Yeah.
It's hard to tell your boss, we built a mess.
It does. It requires telling the guru, we don't care how smart you are. We care how clear your code is. It requires telling the team, we aren't going to just start coding. We are going to model this until we can verify it.
It's interesting how this all circles back to professionalism. We often think of the hacker as the ultimate pro, right? The hoodie, the green text on the black screen. But CPDM suggests that true professionalism is actually clarity.
Clarity is kindness. If you build something complex and undocumented, you are being selfish. You are leaving a trap for the person who comes after you. If you build something simple, formalized, and well-modeled, you are being a professional. You are making the system sustainable.
It really changes the view of what a good job looks like. It's not about how hard you worked. It's about how easy you made it for the next person.
And remember the goal of inspection. If you can inspect the work and verify it, you eliminate so much waste. You stop that cycle of fix, break, fix, break.
So let's bring this home. We've covered a lot of ground. If we want to get out of the swamp, what are the steps?
Step 1, diagnosis.
Hmm.
You have to identify if the pain you're feeling is intrinsic complexity, the problem is just hard or artificial complexity. Our solution is messy.
Step 2, look for epicycles. Are we adding layers just to patch a bad core model? If so, stop adding layers. Fix the model, even if it hurts.
Step 3, beware the guru. Don't idolize the developer who hoards knowledge. Prioritize system clarity over individual ego. If only one person understands it, it's broken.
And finally, intellectual control. Stop guessing. Stop relying on testing quality in. Start designing quality in through formalism and inspection.
It's the journey from being a craftsman who hopes for the best to an engineer who guarantees the result.
And I imagine for the managers listening, it's also about sleep. Sleeping better knowing the project isn't held together by duct tape and Dave's good mood.
Exactly. It puts the agency back in your hands. That's the empowering part of CPDM. You aren't a victim of complexity. You are the architect of your own clarity.
I love that. Well, as we wrap up this deep dive into CPDM and the work of Christopher Sandall, I want to leave you, the listener, with a challenge.
It's the question that really drives this whole methodology.
Look at the most complicated, frustrating problem on your desk right now. The one that makes you want to pull your hair out, and ask yourself, is this problem actually complex? Or have you just built a really impressive epicycle because you're using the wrong model?
Sometimes the hardest part isn't solving the problem, it's admitting you've been solving the wrong one.
Thanks for listening to The Deep Dive. Go find those simple ellipses. We'll see you next time.